sound wave is longitudinal. That longitudinal means cannot be polarized. Cannot be polarized. You can't polarize sound wave. Factors affecting velocity of sound. Factors affecting velocity of sound in air. Velocity of sound in air. Factors affecting velocity of sound in air. Number one, we have temperature. And number two, we have wind. Please, you have to know this one. Pressure does not affect the velocity of sound. Pressure does not. Pressure does not affect. Pressure does not affect the velocity of sound. Pressure does not affect the velocity of sound in air. Pressure does not affect it. So temperature and wind are the major factor. And velocity is proportional to the square root of temperature. So you have V1 over V2. That will be square root of T1 over T2. That's it. And then we know that velocity of sound in solid is greater than velocity of sound in liquid. That means sound travels fastest in solid and it travels least in air. So sound travels fastest in solid and then least in air. We should also not forget that velocity of light is higher than velocity of sound. Light travels faster than sound. And that's the reason why during the thunderclap, you will see the lightning flash before you hear the thunderclap. Because light travels faster than sound. Lastly on this topic, we have echo. And V is 2S over T. Perforated walls. Perforated walls. Perforated walls. So parts are used to reduce the effect of echo and what? Reverberation. The difference between echo and reverberation is echo is just a single reflection of sound, while reverberation is multiple. Perforated walls or parts are used to reduce effect of echo and reverberation in studio. This topic 21 is not difficult, is not much. Effect of echo and reverberation in, I don't need to put in studio and auditoria. So that's the end of that topic. Apart from row 1, others adjust your seat to the front. If you don't adjust, no school until 2035. Adjust it. We're not many, we know, but we'll still adjust. Adjust it. Those in front of the screen, I'm not adjusting here. Can you adjust forward, please? So we'll take some questions now on physics on this topic. It's very short. Father, I'm tempted not to take 10, so it's too simple. But let's not break our covenants. Question 1. A cannon is fired. A cannon is fired. A cannon is fired from A, capital A. A cannon is fired from A. Full stop. After how long is the sound heard? After how long is the sound heard? After how long is the sound heard? At the town B. At the town B. At the town B. At the town B. 6.6 kilometers away. At the town B, 6.6 kilometers away. In bracket, velocity of sound in air. Velocity of sound in air equals 330 meters per second. Velocity of sound in air equals 330 meters per second. Classwork, do it. Now, some of you will miss that question, and we have done something like that before. Because nobody told you that something was reflected, though. Don't go and use this formula, you'll get 0. The other word many of you use. They didn't say it went and then reflected and then come back to you. They didn't say that. So using 2s over t does not make sense. Read the question, let me hear. Yes. At town B. Yes, they didn't say, how did he go and come back? There is a difference between that one. So we have speed. Speed is distance over time. That's all, though. Don't go and be doing 2s over t. How much speed are we given? 3 what? 330. Distance, how many kilometers? That will be 6,600. Abi? All over t. So you have 330 t equals 6,600. Our t will now be what? 6,600 over 330. What's the answer? That's the answer, 20 seconds. So it's not every time you'll be using 2s over t. When you hear about reflection, I shot something and boom, and how many seconds will it take for me to hear it? And it has gone and it has been reflected. That's echo concept. You now use that. Go on 2. A sound of frequency 512. A sound of frequency 512 hertz. 512 hertz reaches a listener. A sound of frequency 512 hertz reaches a listener 100 meters away. Reaches a listener 100 meters away. Reaches a listener 100 meters away. Full stop. If the sound travels, if the sound travels in air at STP. In air at STP. Comma. What is its wavelength? What is its wavelength? What is its wavelength? In brackets, speed of sound in air. Speed of sound in air. Speed of sound in air equals 330 meter per second. 330 meter per second. Oh yeah, classwork, solve it. Are we true? Forget about STP or no STP, just do it normally. The same thing that we have been doing. Velocity is F lambda, isn't it? So don't be deal, don't be afraid. So V is F lambda. What are we looking for? Is it wavelength? So wavelength is what? V over F. What's your V? 330. What's our frequency? 512. What do you get? 64 meters. That's your answer. Raise your hand. Let me see. So all of you did not get it. Why? That's the formula we used yesterday now. Most times, V is F lambda. It's still applicable to sound wave. Point number what now? The velocity of sound in air. One parent came yesterday to the admin office with the daughter. I'm sure the daughter is here. She has not submitted a jam form. I'm telling you. Yesterday. And the mother is saying, what can we do now? Jam form. No, I'm sure the girl has not been coming to lesson. She just leaves house and go to her husband's house. And she has been paying lesson fees since February, since January itself. That one has mental issue. I don't know whether she's here. So many strange things we see in Adams College. Jam of next week. Right, the velocity of sound in air. The velocity of sound in air at 15 degrees Celsius. The velocity of sound in air at 15 degrees Celsius is 340 meters per second. Is 340 meters per second. 340 meters per second. Full stop. Calculate the velocity. Calculate the velocity. Calculate the velocity at 47 degrees Celsius. Calculate the velocity at 47 degrees Celsius. Oh yeah, solve it. Use the formula. What's the formula, class? V2 square root of IB. Oh yeah, do it. V1 over V2. Don't forget to convert the temperature to Kelvin. T1 over T2. You are true, raise your hand. Someone has the pressing calculator. What V1? 340. What V2? What's temperature 1? How many degrees Celsius? Eh? So that'll be 15 plus 273. What's T2? 47 plus 273. Some people will not convert. That's how I'm showing them. 340 over V2. What's 15 plus 273? 288. 147 plus 273? 320. So I'm going to have 340 over V2. All these richless things, what do you get? Everything here. 0.995. 0.95 V2 equals 340. V2 would now be 340 over 0.95. Divide, what do you get? 35. You got something similar like that? Raise your hand. Very good. Start building your confidence level. Number what? In which of the following media? Daniel, is Daniel in the office? In which of the following media is speed of sound in air? Daniel or Michael, please help me call Mr. Sherman that there is class. I'm not sure he's aware of the arrangement. Daniel or Michael. In which of the following media is speed of sound the least? Speed of sound the least. Option A, air. Air. Option B, brass. Brass. Option C, water. Water. Option D, wood. Wood. W-O-O-D. Wood. Pick one answer. You have 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Class, what's the answer? Very good. Number 5. Metal cables are used. Metal cables are used as telephone wires. Metal cables are used as telephone wires. Metal cables are used as telephone wires because option A, they are cheap. They are cheap. They are not expensive. Option B, they are sourced locally. They are sourced locally. They are sourced locally. Option C, the speed of sound in them is very low. The speed of sound in them is very low. The speed of sound in them is very low. Option D, the speed of sound in them is very high. The speed of sound in them is very high. Pick one answer. You have 5 seconds. Have you got your answer? What's the answer, class? D. Speed of sound in them is very high because sound travel fastest where solid. Next question. Number what? The sound of an electric bell. The sound of an electric bell. The sound of an electric bell. The sound of an electric bell dies down. The sound of an electric bell dies down slowly when the air dies down slowly. When the air is slowly pumped out. When the air is slowly pumped out. When the air is slowly pumped out. When the air is slowly pumped out from a bottle. From a bottle because option A, sound needs a material medium. Option A, sound needs a material medium. Sound needs a material medium. Option B, sound can pass through a vacuum. Sound can pass through a vacuum. Sound can pass through a vacuum. Option C, the wavelength of sound becomes greater in the bottle. The wavelength of sound becomes greater in the bottle. The wavelength of sound becomes greater in the bottle. The wavelength of sound becomes greater in the bottle. Option D, sound cannot pass through the bottle. Sound cannot pass through the bottle. What's the answer, class? A, sound is what? Mechanical. Therefore, it requires a material. All other things they are saying, they are beautiful nonsense. Number what now? Number 7. A girl standing some distance. A girl standing some distance from the foot of a tall cliff. A girl standing some distance from the foot of a tall cliff. From the foot of a tall cliff. A girl standing some distance from the foot of a tall cliff. Clap her hands. Claps her hands. And hears the echo. Clap her hands and hears the echo. 0.8 seconds later. Claps her hands and hears the echo. 0.8 seconds later. Full stop. Calculate her distance from the cliff. Calculate her distance from the cliff. Calculate her distance from the cliff. In bracket, speed of sound. Speed of sound. That's sweating. Sorry, baby. Speed of sound in air equals 320 meters per second. Speed of sound in air equals 320 meters per second. Class work, solve it. You are Trabi. To see your face. Bale. You have been stressed. So our speed, V is 2s over t. What are we looking for? Is it distance or velocity? So you have 2s is vt. So our s will now be vt over 2. What's that v? How much? 320. What's time? 0 points over 2. What's the final answer? 128 meters. That's your answer. Raise your hand. Very good. Number what, class? Number 8. Almost the same question. An observer hears an echo. An observer hears an echo. An observer hears an echo. 1.26 seconds. An observer hears an echo. 1.26 seconds. 1.26 seconds. After blowing a whistle. After blowing a whistle near a cliff. 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 Full stop. Calculate the distance of the observer. Calculate the distance of the observer from the cliff. Calculate the distance of the observer from the cliff. Distance of the observer from the cliff. In brackets, speed of sound in air. In brackets, speed of sound in air equals 330 meters per second. Speed of sound in air equals 330 meters per second. Class work. Anyone true? We're working like machine now. What's the answer? I can't hear you. Or is it 50 over 2? What velocity? What's time? Over 2, Abby. Final answer. 207. Question number what now? Number 9. During a thunderstorm. During a thunderstorm. During a thunderstorm, the sound is heard over a long time. During a thunderstorm, the sound is heard over a long time. Full stop. This phenomenon is referred to as, during a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as, option A is superposition. Superposition. Option B, reverberation. Reverberation. Option C, refraction. Refraction. Option D, diffraction. Class, what's the answer? Reverberation. Number 9. Number 10. Sound. Sound is heard from far distances in the night. Sound is heard at far distances in the night. Far distances in the night. As a result of option A, reflection. Daniel. Option B, refraction. Let me call Mr. Shuemi. And it's class by 9. Option A is what? Option B, refraction. Option C, reverberation. Reverberation. Option D, Doppler's effect. You've called him. Okay. Doppler's effect. Pick one. I'm sure all of you will miss this question. What's option A? What's B? What's C? What's D? You must pick one, everybody. Those that want admission must pick one. If you miss it, we're not going to beat you, so just pick one. I'm going to be asking to raise your hand. So if you don't raise your hand, that means sometimes I don't want to go to school this year, so I'm not raising your hand. So raise your hand. We're not going to beat you. You chose reflection. A, raise your hand. Raise it very well. Okay. You chose refraction. Raise your hand. Okay. You chose reverberation. Raise your hand. Okay. Some people didn't want to raise their hand. See, last jam class, few days to jam, many students were gripped by fear and guilt. Especially the female. They came to my office. They knelt down. Said, I was using phone in those, and I'm sorry. Please pray for me, forgive me. Another one came. Sir, I was taking pure water. I'm in Jubil. I just take pure water in the night. I don't pay. Forgive me. Sir, this and that. A lot of them. And I pray for them. Honestly. When you come to a college where we are praying for you, I pray for you a lot. With my wife, God, they must pass. Those who have challenges, they must. So when we come to a place where they are praying for you, where they are not doing wrongs, it's dangerous for you to misbehave or to do something strange. Otherwise, prayer no go work for you. Apart from that, judgment can even come on you and say, that man, they suffer. Sunday was here, Saturday. Today should be a public holiday. I should go to the beach and relax. True. Or go to the cinema and watch a movie, stay under the AC, come out. That's what holiday is meant for. If I tell my child that there is holiday today, they'll be happy. So I just want to teach. That's why I said there is class. So and I have to force them to come. So I would have loved to just be sleeping, watch movie. Maybe you don't know, I have Netflix in my house. I have. And I've not watched many movies. In fact, I've watched, how many have I watched this year? I can't remember, but very few. So I have all those facilities. So it's very important for you to know that the effort being spent on you, you must quantify it well. And then you don't misbehave. I've been saying about you don't misbehave. All the things you have stolen, return them. The one that belong to your colleagues, return them. You are stealing Lamlad, you are using it. You are stealing Jam Series. Return them. If you don't have the name, give it to the governor. Help me call this name. And you don't just go and drop it then somewhere and say, I've dropped it. No. That's still stealing. You stole somebody's book, went to drop it at Afadogun Road and say, after I've dropped it. You have not. So don't allow small thing to hinder you. Small thing, small lying, go and use my receipt to enter class. Go on. You didn't pay, we know, but we plan it. So two of us will share the money. Those kind of life, you will just fail. So some came to my office, they were kneeling down, and I was praying for them. I know some girls that knelt down that I pray for. They go above 300 though, but they will have scored more than that. I know. So don't go and say, it doesn't matter. What is don't kiss faith. I will keep it. So raise your hand now. I'm coming back to that's the story. If you don't raise your hand, come and say, sir, come and pray for me. One day, say we should raise our hand. I didn't raise our hand. I'm thinking of getting. My mind can't tell you saying at 211 I go get. Now your mind is correct. And now your mind is correct too. We are the one that will not disobedience. Disobedience is your problem. People are planning to beat Oluchi and Co. I've not forgotten, you know. Yesterday I was resting, that's why I didn't beat you. Today, by 9:10, I must beat all of you. 9:10. So once it's 9, leave your English class. Pankere. Oh, you guys are stubborn. You don't obey simple instruction. Option A again, raise your hand. Reflection. I see many hands now. By preaching the work. Put down your hand. Option B, raise your hand. Refraction. Option C, raise your hand. Reverberation. Option D, raise your hand. Doppler effects. Very good. If you pick reflection like my shirt here, you are wrong. Odo. If you pick reverberation, you are wrong. What is reverberating? You are wrong. The answer is between Doppler effects and refraction. If you pick Doppler effect, you are also wrong. The answer is refraction. Yes. Only about 7 people here got it. And they are getting inside, and guess what? Refraction. Refraction. Why? During the night, what happened? The density of air is very high. Temperature has also reduced. There is different layers, atmosphere and down. They have different density at that time. That's the same phenomenon that happened to land and sea breeze. And then sound can travel. If you stay here now and they are playing music at open space at Mushin, in the night you will hear. That's why your neighbor will always complain. Some years ago they used to complain, sir, we can't sleep. Adam studio and we just be hearing crow in the kitchen, knife, spoon, crow by 2 a.m. I don't know. Because that thing you are doing now, in the next 3 buildings, they can hear you. Sometimes in the night, when you sit down, or when you want to go to the restroom, you will hear the tick time of your wall clock that you don't hear during the day. Tick time. Sometimes you even say, what's in the happen? Tick. You will hear it clearly. You know? So that phenomenon, whereby sound travel for a long distance during the night, is as a result of refraction. Result of what class? Different densities of media. The atmosphere and the earth have different densities at that time. And don't forget that in refraction, something is traveling from a lower density to a higher density. We say from denser medium to less dense, or from what? Less dense to denser medium. So what is Doppler effect? Doppler effect is, I stand here now. Anyway, that's part of the next topic we are doing now. We are going to the more interesting part of sound. You know, the characteristics of sound. So we hear about Doppler. But let me explain. They are doing party here now. This speaker, they blast music. And then you are coming like this. You know, nobody call you, just they come. Want to come and see what is happening. As you are coming, as you are moving closer, the sound intensity and frequency will be increasing as you are moving closer. You'll be hearing it more louder than before. Louder. When you now get here more, you have to close your ear. The loudest effect will be heard. So that variation in frequency or intensity of sound as you are moving closer to the sound source is called Doppler effect. If you're also moving away, the sound intensity will be reducing if it's stationary. Sometimes you'll be on campus. You'll be at the bus stop. You are waiting for cab. And then for shuttle. Just sitting there, you are tired. Just hear some big boys from nowhere. Big boys. You are just standing on the bus. You want to pay 20 naira to enter. Just hear some big boys. Open roof. Car. Ching. They just tell you, you'll be feeling bad. As the sound is coming closer to you, it will be increasing intensity. When it gets to you, the intensity is high. They may even park beside you to oppress you more. Not because they want to carry you. How far are they? They've gone. And then the sound intensity will now begin to increase. So as you're not going away now, sound will now be going down. That's Doppler effect. the variation in frequency of sound as a result of relative motion between the source of sound and the observer. So when the frequency is changing, that's Doppler effect. So we are finished that topic. We go to the next topic. Topic 22. Characteristic of sound wave. From tomorrow, we'll start checking our jam center. Characteristics of sound waves. Your center will favor you. Listen to me. No matter the center they give you, you score above 300. No matter what happens in your center, you score above 300. During fellowship, I told you that time. I will even call the girl. I pray. Okay, today is Tuesday. That should be holiday today. Doctor Tusumu. We'll tell you. They're not sleeping. I am. They're sleeping. These guys are always stressed. Okay. So we have noise versus musical notes. Noise has what? Irregular frequency. And most of the things you guys are listening to in Nigeria that you call music, they are noise. Irregular frequency. Musical notes, irregular frequency. Regular. Then, for musical notes, we have what we call Pif Cola. Do you remember Pif Cola? Pif Cola. So the characteristics of this one, characteristics now, this is pitch, this quality, and this loudness. The pitch depends on what, everybody? Frequency. Quality depends on what? Overtone. Loudness depends on what? Amplitude. That's Pif Cola. Okay, so we have this one. Let me see the syllabus. I don't want to leave anything out. Okay. So from there we go to string instruments. String instruments. Our frequency of sound. We have to square root of tension. So we have F1 over F2. Square root of tension 1 over tension 2. F1 over L. 1 over L. So we have F1 over F2 equals L2 over L1. And number 3, F1 over square root of mu. That means F1 over F2 will now be square root of mu2 over mu1. Inverse relationship. And then we have F is equal to N all over 2L, square root of tension over mu, where N is number of loops. Number of loops. Then string instrument, you have this. This is our L. This fundamental stage. Fundamental. So in fundamental stage, what we just have is L is lambda over 2. Or lambda is 2L. Then number 2, we have first overtone. First overtone. That's first overtone. So we have L here. So our L now will be 2 times lambda over 2. So L is lambda. Then number 3, second overtone. Second overtone. So if you are 10th overtone, we are going to have 11 cycle. 11, we call it segment in physics. First overtone, 2 segments. Second overtone, 3 segments. You can draw for and say which overtone is this. So L now will be 3 into lambda over 2. First overtone, we're going to have 2 here. Second overtone, we're going to have 3 here. Seventh overtone, we're going to have 8. So they have, that sequence. Fundamental, L is lambda over 2. First overtone, 2 circle. Second overtone, 3 circle. Class, how many circles are you going to have for fourth overtone? 5. If you have 8 cycles, how many overtone are you? 7th. 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 Doctor, you are still sleeping?
Yeah, I just woke up like a while.
Please call me on a normal line because I've been trying to call you. I couldn't get you.
All right, sir.
It's not easy. Doctors have to rest. So much of work. So much work. So first overtone, I will explain with example. You don't have problem. It's simple. Yeah, very, very interesting. Open tube, stroke pipe. Say open tube and pipe. Hello?
Yes, I'm on, sir.
Hello? I can't hear you.
I can hear you.
Can you hear me? Okay, how are you?
I'm fine, sir.
Please speak louder. Your jam that you wrote in your center, what time were you supposed to write the jam? What time?
Like 1.
1. But you wrote your own jam. What time?
Like around 8 to 9.
9 p.m.
Yes, sir.
9 p.m. What did you score in your jam?
3:30.
3:30. I just want to find out again. Our exam was 1, but they planted my daughter in a dangerous center. Generator broke down. Computer no dey work. They were all frustrated. And then I should start by 1. They didn't start. They were calling me. I was praying for them. They started their jam by 9 p.m. Already frustrated, already disturbed. Disturbed, that's the language. And by the time the jam result came out, 3:30. As I called her now, she's in UI. She's studying medicine, part 4. Any center they put you, you score above 300. There's some people who have been praying here. Oh God, my own exam must not come first. My own exam must not come on Friday. That's not a good prayer. Doesn't matter. If your own exam comes first, then that means you are going to score 300 first. Not that God changed my deal. I want to be the last person. Last person. What does that mean? They should put all of you first. Blast the exam and let me see the results. So it doesn't matter where they put you. Give them fun. So don't allow fear. Can you imagine an exam of 1, they did it by 9 in the night, and they are hostel students. This fundamental stage. So our L is land number 2. But this antinode. So our L is land number 2. Does the same thing with this one. The same thing with string. What happened in string is what happened in open tube. So the same thing, number 2 now. First of all, tone. So I won't draw everything for this one. By the time we saw past square, you can see that they are all simple. You don't have to cram. I'll teach you how to remember first overtone, second overtone, third overtone. The first overtone. So L now be 2 into line number 2. Then 3, second overtone. That's the only thing that can catch all of you. Want to pass jam, keep quiet. Want to score above 300, keep quiet. Or we say normal thing, I no go here. Don't mind me the useless diagram I'm drawing. I didn't draw it well. It's going to resemble glomerulus. Is it like glomerulus? I just say rubbish. Show. Is anything like Bowman capsule? I used to hear some dangerous word in biology those years. Bowman capsule. This L. L is 3 into land number 2. So everything you have in string, they for open tube. At the open end of a tube is antinode every time. Antinode, antinode. Antinode, 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 antinode. So how will I know first overtone? We're going to have a complete cycle. This one is even easy. Second overtone, 2 cycle. Third overtone, 3 cycle in between. Fourth overtone, 4 cycle. The same thing applies to closed tube. First overtone, 1 cycle, complete. Second, 2 cycle, complete. Third, 3 cycle, complete. With example, you will get them. Nancy, are you okay? Don't worry, I'll give you explanation. They are simple. Closed tube. Through pipe. Fundamental. This one is the only different one from other one. This one is land over 4. So why? Antinode and node. That's if we nail the end correction. Land over 4. Fundamental. Others land over 2. Land over 2. This one land over 4. First overtone. So how will I know it's first overtone? One complete cycle in between. So L 3 into land over 4. Second overtone. Because sometimes they will draw for you. They say, what overtone is this? All these are what the Pino has taught you, but some of you have not read that note very well. Give you a comprehensive note. Go and read it. So L is 5 into land over 4. So you can see what is happening in close tube. The first one, land over 4. Second one, 3 into, third one, 5 into. That means you're going to be having odd integral multiple. 3F naught, 5F naught, 7F naught, like that. But even just 1, 2, 3, 2, 3, 4, like that. My beautiful governor here, Glory, she came to me and said, sir, the class for this morning, maybe you should allow us, because we want to raise money to maybe buy a gift for teacher, but they've not paid. I think maybe we should cancel this class so that we can talk to them. Not really cancel, like so that we can talk to them and raise more money and all that. I said, no, we cannot cancel class because of that. But it's very important for you to give to your teachers. Not me or me. Don't think I'm looking for anything from you. All these Opino, all these Amos, all of them, as you are going to write your exam, not until when the result comes out. We call it the art of gratitude. Somebody said, if you are not grateful, then you are a great fool. Yeah. Yeah, if you are not grateful, that's what he said. If you are not grateful, you are a great fool. That's it. All your child, all this, I'm not talking about myself. All your chance. It's to show, they don't need it, but to show some, that you, some years ago, so it in the hostel. Not all these sets or this set. I don't know what's wrong with all these sets. Yes. So in the hostel some years ago, Jam Club was about to over like this. They just invited me, female hostel. The boys also did the same thing. One female hostel, I went there. They switch off the lights. I just enter. They use hand to take me to a place. Quiet, I'm talking. And then by the time they open, come and see table. They have decorated table for me. Food of different caliber. Different assorted food. And then they gave me special gift. I think they gave me a refrigerator. Yes, one floor. I'm not asking to do it because when we start thinking of Adam's one. No. This is from their arts. I didn't tell them. They did poem. They gave speech. They did a lot of things. They danced. They did many things. I sat down like a big boy. As I was eating this one, I was eating fried rice. They gave me pepper soup and peppery soup, brother. They gave many things. Many things they gave me. I didn't tell them. Top floor. 1 year again like that. Ground floor. We are trying to finish program like this. They gave me one complete suit of clothes. Sir, we thank you. We can't love you less. Complete suit. That same set, they gave me kaftan. The Yoruba type, like that. The same set. That same set gave me one powerful, what is it? Canvas, they call it when I was teacher. They gave me one beautiful, one floor. So, sir, we thank you for what you have done. That's how to show gratitude. Will I not forget those ones very early? Never. Never. What if the governor are turned to beggar? give us 10 naira to give your teacher to buy. And so I say I can't cancel my class because of that. But these are the normal things. That somebody come and say, please, I'm giving 5,000 for that thing. I'm giving 3,000. Our church have tried. I'm giving that's how to do things. Not that Victoria and Ibuku and all of them, Basit and this one, they will not turn to beggar. We don't have money. All the money of you have raised for the past 1 month is 1,755 naira. A whole class. We're not beggars, though. So don't think your chairs are beggars, but those are the things you should do. Opano's class before jam. Sir, on behalf of the class, want to appreciate your effort and all that. Then aim on like that. That's what you should do. And it should be generously done, not compulsion that we are forcing you. So every impression is that, how will I pay lesson fee? Why am I going to give anything? That's your thinking. So I told her, I said, we won't cancel class because we want to, you'll be shocked that if I cancel the class, at the end of the day, maybe you're going to realize 2,150 naira from the whole class. We'll not lose on both sides. No class. Money no coming. Class no take place. That's it. Those are the small things you do, teachers, to encourage them. Not because they are looking for wine or anything. No. My teachers are comfortable. So we want to start solving questions so I can use the question to explain to you. Some years ago, when ground floor was ground floor in the hostel, hey, students want to go home like this or go for, they gave me one beautiful, I don't know how to describe that clothes. I wore it, I just put it on everywhere. People said, what, Mr. Adam, this is fine. And my heart was praying for those students that gave me. Not because I don't have clothes, but we are happy when we see our students showing love to us that way. We're happy when I see a student say, Mr. Adams, we love you for what you are doing. You are simply the best. Not because of anything, but that is exactly what the world wants to do. It should be reciprocal, not one-sided love. One person wants to die to ensure that you pass, and everybody is, even ordinary instruction cannot obey. Let's go. Question 1. So we'll be using so many examples to explain to you before the English class and before. Two sound waves. Two sound waves. Two sound waves. Our frequencies. Two sound waves. Our frequencies of 120 hertz. 120 hertz. 120 hertz. And 120 hertz and 100 hertz respectively. Don't put respectively. 120 hertz and 100 hertz. Full stop. Calculates their beats. Period. Beat period. I mean their beat period. Look at that. Well, let me define beat for you. Right. Beat can be defined as a periodic rise and fall. Beat can be defined as a periodic rise and fall in the intensity of sound waves. Beat can be defined as a periodic rise and fall in the intensity of sound waves. That's beat. I've defined it for you before. Can be defined as a periodic rise and fall in the intensity of sound wave. Periodic rise and fall in the intensity of sound wave. So now write next line, beat period, beat frequency first. Beat frequency is F2 minus F1. That's beat frequency. The bigger value minus the smaller value. Class, what's the bigger value? How much? 120. What's the smaller value? So what's the beat frequency? 20 hertz. Is that what they're asking you to find? What are we looking for? Beat period. Class, what is period? 1 over f. That's 1 over beat frequency. So 1 over 20. So what's the answer? 0.05. When sound intensity rises and falls, that's beats. Sometimes when you have a sound system, sometimes it will show you something like this. That's beats. You know, like that. If your own can't show like this, you can't dance, something is wrong with your brain. Because there's no beat here. I do. Then you are dancing. But here, that's beats. The Chinese, they dance to anything in the world. As far as they beat, they're there. Beats. Product rise, they can use 2 sticks together. And they'll be dancing. So the generates beat. They can even use their tongue. You know, those ones, they are strange people to produce sound. Some people are already, they have experience here. Right, round 2. The fundamental frequency of a plug wire. The fundamental frequency of a plug wire under a tension of 900 Newton. The fundamental frequency of a plug wire under a tension of 900 Newton is 200 hertz. Is 200 hertz. Full stop. When the frequency is changed to 400, when the frequency is changed to 400 hertz, when the frequency is changed to 400 hertz, when the frequency is changed to 400 hertz, comma, it changed to 400 hertz, comma, what will be the new tension? 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 Classwork. Therefore, a frequency is prior to the square root of tension. Classwork, do it. F prior to root T. So I have F1 over F2 equals square root of T1 over T2. But yeah, quickly, no time. Later, yeah, quickly. Well, so is there extra class today? Of course. Exam is next week. Because of my beautiful girl here, Alajas, they are not going home. See them. So we have to do extra for people like this who decide to stay back in school and said, I will do my own Eid Fitri later, after I've seen my 349, 352. Inshallah, it will come to pass. So F1 over F2, T1 over T2. Oh yeah, what's F1? How much? 200. What of F2? 400. What's tension 1? 900. Tension 2, nko? Here 1, here 2. 1 over 2 will now be square root of what? Over what? Square both sides. Do you know mass? You square both sides so that the square can disappear. That will now be 1 over 4, Abi. That will now be 900 over what? T2. Cross multiply. T2 will now be 4 times. Final answer. Newton. If you remove 1 0 from that 3,600, what do you get? That is somebody's jam score. Yeah. We've been praying for you to come to pass. Question 3. Question 3. The amplitude of a sound wave, Michael, well done. That's a great job. The amplitude of a sound wave. The amplitude of a sound wave determined is the amplitude of a sound wave determine its option A, frequency. Frequency. Option B, quality. 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 Option C, loudness. Loudness. Option D, pitch. Pitch. Class, what's the answer? Loudness. Your result will be loud. Say, 59 kilo day. A steel wire of length. Next question. A steel wire of length. The result that will make your enemy to open mouths. That they can't show. Kilo a day. I want 120. What do I buy 40? Kilo day. It can happen. No? That's God for you. God will surprise you. A steel wire of length 0.50 meter. A steel wire of length 0.50 meter is stretched. Is stretched between two fixed points. So between two fixed points. And a second overtone frequency. And a second overtone frequency. And a second overtone frequency is 600 hertz. 600 hertz. Calculate the speed of the wave in the wire. Calculate the speed of the wave in the wire. The speed of the wave in the wire. Claire, which overtone did they give you? So, I've taught you, you want to draw second. This is fundamental, only one. First overtone, now two. Second overtone, now three. This is two. This is second overtone. So when you hear second overtone, draw three. Okay, I don't need to draw anything before I get the answer, but just to explain to you. Fundamental, only one. First overtone, only two. Second overtone, make it three. Third overtone, make it four. Like that. Just add one. So our L is 3 lambda over 2. 3 into lambda over 2. This lambda over 2 is for node to node. And there are 3 of them. This is why you have 3. What's the length they gave you? How much? 0.5. So you have 3 lambda over 2. So 3 lambda. What's 0.5 times 2? 1. So lambda will now be 1 over 3. I mean now, meter. V is what? F lambda. What's the F they gave you? 600. What's the wavelength? So what's the answer? 200. That's it. 200. Next question, number what? So please go through it. It's not difficult. Solve many past questions now when you are free. You know. In a closed tube, come on. In a closed tube. In a closed tube, come on. If the fundamental frequency is 200 hertz. If the fundamental frequency is 200 hertz, comma, find the frequency of the fifth overtone. Find the frequency of the fifth overtone. Find the frequency of the fifth overtone. Class, did they mention open or close? Close. Anything close. Now, integral odd number. So for close, just have F naught. Next one, go 3F naught. Next one, go 5F naught. Next one, go 7F naught. Next one, go 9F naught. Next one, 11F naught. That's it, like that. There's a formula of 2N plus 1 F naught. But sometimes in the exam, you can forget formula. Sometimes in the exam, you can forget spelling. So this is the first overtone, because it is closed. Second overtone, third one, fourth one, fifth one. As I've said, the formula is Fn is 2n plus 1 F naughts. So they have to find the 10th overtone. That will be 21 F naughts. 2 times 10, 20 plus 1, 21. Fifth overtone, 2 times 5, 10 plus 1, 11 F naughts. So our F5 now is 11 F naughts. But if it is open, this is for open now. Now be N plus 1 F naughts. This is for close. Closed. This is for open. So F5, 11 F naughts. Oh yeah, now. So our F5 will now be 11. What's F naughts? 200. So what's the answer now? 2200. Abby? 2200 arts. Two. F5, 11 F naughts. Don't let your neck remove. Oh. And time for yesterday too. 11 F naughts. So that's F5, 11 F naughts. Next question. Class, do you know wind instruments? Wind instruments. They are the one you place in your mouth, Abby, and blow. Like trumpet, Abby. Saxophone. I was watching Family Feud on one day like that. He asked one woman, what is wind instrument? Give an example of wind instrument. She said, tongue. Tongue. I wanted to cry. Somebody has already, one lady has already gotten 148 points. She only needed 52 points for them to win 5 million. To make 200. And she spoiled everything for the woman. She cannot get 52. Was saying rubbish on national telly. Wind instrument, he was saying tongue. How can tongue be instrument for sound? When she's not from China. You know. So the wind instrument, we have saxophone, trumpet, clarinet, Abby, trombone. What of string instrument? Is piano a string instrument? Yes, it's a string instrument. Your piano, there are string inside. 18 string inside. Is a violin a string instrument? What of harp? What of guitar? What of violin? Okay. Let's try. Next question. Number what? Number 6. As the air column of length L, as the air column of length L, as the air column of length L in an air pipe decreases. In an air pipe decreases. In an air pipe decreases. Comma. Frequency of the stationary wave emitted. The 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 frequency of the stationary wave emitted. A decreases. A, decreases. Option B, increases. Increases. Option C, varies as L squared. Varies as L squared. Option D, varies as square root of L. Varies as square root of L. As the air column of length L in an air pipe decreases, the frequency of the stationary wave emitted. Oh yeah. For close to. Our fundamental frequency is what? V over 4L. That's what you have. Then for that fundamental. For open tube, our F naught is what class? V over 2L. Oh yeah. What did you now say in the question? Read the question, everybody. As the air column, that's LO. Yes, what happened to it? Decreases. Class, what's the relation between frequency and length? That's it. Too. So when L is decreasing, what happens to the frequency? Option what? That's the answer. Frequency and length are inversely proportional. Let's go. Next question. Number what? The frequency of sound produced. The frequency of sound produced by a vibrating string. By a vibrating string of length 9 meters. Of length 9 meters is 300 hertz. Is 300 hertz. 300 hertz. Full stop. Find the frequency when the length. Find the frequency when the length becomes 4.5 meters. Find the frequency when the length becomes 4.5 meters. Classwork. Go and look at the relation between frequency and length. And then combine the two of them. Be careful. Be fast, rather. Tashemi will soon be here. Let's finish this one. Are you true? Class, relationship, is it direct or inverse? Can even say it here for string and for pipe, they are all inverse. F1 over F2 equals L2 over what? What frequency 1? 300. Frequency 2? L2. L1. 4.5 year 1, year 2. Answer 600, Abi. Don't spend too much time on calling like this. Just get the answer and smile. Number what now? A sounding tuning fork. A sounding tuning fork. A sounding tuning fork. F-O-R-K. Is brought near the open end. Is brought near the open end. Is brought near the open end. Is brought near the open end of a pipe. Is brought near the open end of a pipe containing air. Containing air. And the loudness of the sound is observed to increase. And the loudness of the sound is observed to increase. Is observed to increase. Is observed to increase. Full stop. Is observed to increase. Full stop. This observation is due to option A, echo. Echo. Option B, resonance. Option C, interference. 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 Option D, reverberation. Pick one answer. Class, what's the answer? Resonance. Resonance. What is resonance? The process whereby a vibrating body set another body into what? Vibration with its own fundamental frequency. Now listen, when a tuning fork is loaded, what happens to its frequency? The frequency is reduced. Note it down. Note. I've given you the note before. I know you have forgotten. When a tuning fork is loaded, L-O-A-D-E-D, its frequency / pitch is reduced. When a tuning fork is loaded, its frequency / pitch, P-I-T-C-H, is reduced. When a tuning fork is loaded, a frequency / pitch is what, class? Reduced. All right, let's go. Number what are we? Number 9. Good. Number 9. If the distance from a point source of sound is doubled, if the distance from a point source, if the distance from a point source of sound is doubled, comma, by what factor? By what factor does intensity decreases? 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 Class 4, try it. I have option, but I won't give you option. The first thing is to know relation between intensity and distance. Look at intensity. Intensity is P over 4 per R squared. I'm sure you have not seen that formula before. That means intensity is what? 1 over R squared. That's relationship. That's intensity. That P is power of the rate at which sound energy is transmitted. That's that P. The unit is power. Is watts. Now, what can you say now? Our intensity is what? Inversely proportional to the square of the distance. Like your inverse square law. What does happen to the R? R is what? Check the question. R is what? When you increase R, what happens to I? Decrease. So when you increase R by factor 2, our I will decrease by what? Factor 4. That's the answer. I decreases by factor 4. And these are likely questions, no. We're not just doing something for fun. By factor 4. I decreases by factor 4. Inverse square law. Look at that formula. The last question. Last question. Find the velocity of the wave. Find the velocity of the wave in the figure below. Find the velocity of the wave in the figure below. Draw. At 1 p.m. today, we still have revision, physics and chemistry. So when are we ending? I don't know. Just know we have class. Don't salo. They must say there will be biology on Sunday. I hope you had it yesterday. So we'll announce the time. So will it affect our mass? I don't think so. I'm just looking for venue. The mass will be exclusive for those who are doing jam mass. Exclusive. Don't draw what you think. Draw what is on the board. You get 3 circles. Class, for having 3 complete loop like that, Omolola, how many overtone is this diagram? Third, because it has 3 circles. 1, 2, 3. Very easy to remember. Once you have 3 circles, third overtone, 2 circles, second overtone, 4 circles. So closed tube is very easy to remember. Even the open tube too. Just count how many circles you have. 1, 2, 3. Third overtone. But you can draw for you and say which of the following represent third overtone. You count 1, 2, 3. So how will I remember all this jargon? Very easy. Look up. Ordinary one like this. Ordinary one like this. L is what, everybody? Land over 4, Abby. Abby, land over 4. So what this one? Land over 4. This one included 3 land over 4. This one, 5 land over 4. This one, how much? That's it, no cramming. Don't forget, odd number 1, 3, 5, 7. So our L now will be 7 into land over 4. Mr. Adam, how do we get 7? If you are alone like this, land over 4. They can't include you like this. 3 into land over 4. You can't be from here to here. 5 into land over 4. From here to the down. 7 to land. You can prove it yourself. But that will waste time. This is antinode. This is node. This is node. This is node. This is node. From here to here, land over 4. From here to here, land over 2. From here to here, land over 2. From here to here, land over 2. SCM now 4. 1 lambda plus 2 lambda plus 2 lambda plus 2 lambda. That is 7 lambda over 4. So the exam, you can prove it yourself. But we are smart. Only one fundamental stage, land over 4. First overtone, 3 into land over 4. Next one, 5 into land over 4. Next one, 7 into land over 4. Like that. Odd number. What's your L in the question? 20 watts. You put 28 here. That will be 7 lambda over 4. 7 lambda will now be 28 times 4. Have you now? 7 lambda will now be how much? Is it 112? Our lambda will now be 112 over 7. Calculator, what do you get? 16 cm. Convert to meter. Abi now. Convert to meter. Or else sleeping. She's not doing my marker. 0.16 meter. What are we, is it velocity we're looking for? So now the V is what? F lambda. What's that F? 256. What's the wavelength? Multiply the two, then what do you get? 40.96 meter per second. That's my 10, Abby. So I think I'm even through. Sir, eclipse of the sun. It happened yesterday. I said it's not going to take place mostly in Nigeria. They said it. Yeah, it was mostly in the US. Part of Port Harcourt also viewed that, for about a few minutes. Yeah, it was not visible in Africa at all. Sorry about that. So I have mass later in the day in all the classes. I'll be there. Then by God's grace, after class by 1, we'll be back for more physics and more chemistry. We are through with the old sound waves. So I'm moving to light in the afternoon, topic 23.